Lesson 10, Creating a Data Guard Broker Configuration. So in this lesson, we're going to focus on two main topics. One is creation of a Data Guard Broker configuration and how to manage Data Guard Broker configuration. So these are the two main topics. So I will divide this lesson into two sections, and I will cover first section and I will show you one short demo, and I will cover second section and I will give you another short demo. Before creating Data Guard Broker, you will have to check the list of requirements. Your database must be Enterprise Edition, and also it supports single instance and multi-instance, which is a rack database environment. And to take advantage of the latest features, you will have to set compatible equals to the current version of your database. That's recommended. And also, Oracle Net Services network files must be configured for primary database and existing standby databases or file sync instances. When you create Data Guard Broker configuration, the first member that will be registered is a primary database. When you register primary database, you will have to specify net service name to connect to primary database. And then you will add standby database and also file sync instance. Each time you will have to provide net service name to be able to connect to the database remotely. And Data Guard Broker uses special service in the standalone environment. And service name look like this: DB unique name underscore dgmgrl.db domain. The main purpose of this special service is it is to restart database remotely in case of a switchover, in case of a failover, in case where you convert physical standby to snapshot standby to physical standby database. If your environment is a RAG environment, ClusterWare will take care of the restarting up of primary or standby databases. So we don't have to register this special service in RAG environment. But this is required in the standalone environment. And next requirement is you will have to start daemon process. In the previous lesson, I showed you this demo. By setting Data Guard Broker start equals to true, you can start daemon process. And also by setting it to stop false, you can stop daemon process. And primary database must be configured in archive log mode. Makes sense? It's a Data Guard environment. And all databases must be mounted or open. And Data Guard Broker daemon process, it uses configuration file specified in this location. So we have a path of a Data Guard Broker configuration file. So daemon process will access to file in this location. If this were a RAG environment, configuration file must be in the shared location. Another thing is all the current remote log archive destination must be cleared, because log archive desk eventually managed by Data Guard Broker. So this must be cleared. And the other one is you must use a SP file. because daemon process it also update SP file when you change it. Data guard broker control the parameters. So in order to update SP file parameter dynamically, so you will have to use SP file. If you use broker, use enterprise manager, cloud control, or data guard broker command line interface to update database parameter values. If you update any parameter, actually data guard broker control the parameter through SQL Plus, then data guard broker will complain it. So it's better to use data guard broker command line interface to update data guard broker control the parameters. And also configuration file under Oracle Home DBS directory or location where location in this location specified in the data guard broker configuration file, you will see data guard broker configuration file based on any parameter setting or in the default location, configuration file will be created automatically. So this file will be managed by daemon process. And also we have a log file. The broker log file contains information recorded by daemon process. And also there is one file for each instance in the broker configuration. So in our environment, for Boston primary database, under trace directory, you will have one log file for data guard broker. And also in the London database and also London 2 database has their own trace, the log file under trace directory. So you can actually view this data guard broker log file to understand daemon process activities. Now let's take a look at how to create broker configuration. In order to manage primary database and standby databases using data guard broker, you must create data guard broker configuration. So to do so, you will have to access to data guard broker command line interface, and then you will register primary database as a first member in the data guard broker configuration. And then you're going to add standby database, and then you're going to add file sync instance. Finally, you enable configuration including databases, and also you will have to define redo transfer service. So where to transfer redo. You can actually update SQL any parameter through the SQL Plus, but in this lesson you will see another way to define redo transfer service path. So we're gonna use the routing rules to specify redo destination. Okay, so let's take a look at the preparation part. You will have to update log archive dest 2 and 3 in this example, and the current setting is current setting is to define remote log archive destination. So if a log archive dest is log archive dest is defined to configure remote log archive destination, then make sure you set equals to null, because that way data guard broker can manage it. And then you're gonna make connection to primary database. You can make local connection, you can make remote connection, or you can actually grant the sys data guard the privilege to a user as well. So you can actually go with the sys user, sys data guard, or you can actually grant this data guard privilege to another user to log in. And this is a command to create data guard broker configuration, create configuration dr solution as a primary database. Dr solution is data guard broker configuration name. As a primary database is Boston, and Boston database is DB unique name, and connect identifier is Boston, and this is net service name, so TNS name entry. So after you create data guard broker configuration and then you register primary database, when you type show configuration, it will show you current primary database in the configuration. And then you're going to add a London physical standby database. So you add the database, add the connect identifier is London, and then show configuration. So you have a primary database and London standby database. And then you can add far sync instance, Boston far sync, as the connect identifier is Boston far sync. So this is a net service name. So show configuration, it shows you newly added configuration. And then finally, you enable configuration. So show configuration, and my configuration name is a DR solution that is composed of one primary database, one far sync instance, and one physical standby database in this example. Now, let's define redo transport service. Redo transport service, transport service rule. We can use log archive depth parameter, or you can use one database data guard broker property. But in order to define more complex redo transport service path, you can use redo route broker property. So it allows more complex routing to be defined. Using redo route, we can support cascaded configuration, and also we can support far sync configuration. We can also support real-time cascading, and without real-time cascading, we can also support rules dependent on which database is currently primary, and support the new fast sync configuration. So there are lots of things that you can do. Okay, so this is the syntax. You can change the property of a database, and also we have a redo route, and you add the redo route rules. So in this case, local is the default value, and in this position you can specify DB unique name. So you can actually use this syntax. We better look at actual example here. I better show you this part first. Edit database Boston far sync. Now you are changing property of a Boston far sync. So it is a sender. So this database is responsible to transport redo. And also we have a set property redo route. Now we have a first position and we have a value which is a Boston. Now this is the if condition. If Boston is a primary database, then the rule is active. Boston far sync transport redo to London database asynchronously. So Boston far sync is a sender, London is a receiver if Boston is a primary. So that is actually a simple thing what you can do. So let me come back here. So redo route property has a default value of a null, which is treated as a local, meaning that if current database, which is a local database, is a primary database, then a database that will have a new redo route setting transport redo to final destination. So redo routing rule is active if its redo source field specifies the current primary database. If a rule is active, primary database redo is sent by the primary database at which the rule is defined to each destination specified in the redo destination field of that rule. Async redo transport attribute must be explicitly specified for cascaded destination to enable real-time cascading to that location. The redo route property cannot be set on a logical or snapshot standby database. So you only configure this for the primary and physical standby database. But logical standby database and snapshot standby database can be receiver in the rule. Okay, but you cannot set redo route property for sender, making a logical standby database as a sender or snapshot standby database as a sender. And this is an example. So if you have a primary database in Boston, you have a far sync in Cambridge, and you have a physical standby database in Chicago, and far sync in Schaumburg. So in this example, Boston, this is a redo transport service sender. The redo shipping is done from Boston database. And destination is Cambridge. If local database is a primary database, meaning that Boston database is primary database, then Boston transport redo to Cambridge database. And also far sync Cambridge instance, it transport redo to Chicago asynchronously. But we have a condition, if primary database is Boston. So meaning that Boston transport redo to Cambridge, Cambridge forward the redo to Chicago. That's the meaning of this definition. And if Chicago database becomes primary, then Chicago transport redo to Schaumburg synchronously, and Schaumburg far sync, it transport redo to Boston database asynchronously. So that is to support role transition service. Okay, now I'm going to jump into the demo environment and also whiteboard to show you a couple of demos and also a couple of drawings. Okay, so I'm in the demo environment right now. In this demo environment, I created one primary database, one physical standby database, which called London, one logical standby database, which called London 2. So I want to create a data guard broker configuration in this environment. So what I'm going to do, I will log in as a sysdba. And the first thing what I have to do is I have to set remote log archive destination parameter to null. So show parameter log archive dest. I have a value 2. So I have a given value. And also I have a log archive dest 3 to transport redo to logical standby database. So as you can see, I have two. This setting I think I didn't change here. So I only have one setting, so that's good. So what I can do here is I can set alter system set log archive dest 2, and I will set it to null. Okay, I don't have action 3, and then we're gonna start daemon process. Right now, daemon is running. Okay, so as a part of a previous demo, I started this daemon process, which is good. And also, okay, you know what? I'm in the wrong location. So I will jump into the another demo environment, because I have a 2 demo environment. This is in a environment that includes a data guard broker. So I will jump into another data guard broker, another data guard demo environment. Okay, so I came back to right demo environment. So I will log in as sysdba, and I would set show parameter log archive dest underscore 2. So as you can see, we have London database, and also show parameter log archive dest 3. I have also value here. So to physical standby database, actually a logical standby database. So what I have to do is I will have to set log archive dest 2, and I will set equals to null. And also for the third location, alter system set log archive dest 3 equals to null. So I will set it to null. And I will start daemon process. If it's not running, pgrep minus lf daemon. So it's not running. So I will have to set alter system set data guard broker underscore start equals to true. So I started the data guard broker process, pgrep minus lf daemon. As you can see, daemon is now running out of this. So next thing what I want to do here is I want to connect to physical standby database site. So I will set it to London, and I will log in as a sysdba. First thing what we have to do is, in the physical standby database, you will have to stop this MRP background process. The command is alter database, recover, manage it, standby database, cancel. And then you will have to set show parameter log archive dest. Let me see if we have a second setting. I have a setting here, so I will have to set this null. Alter system set log archive dest to null, and let me check log archive dest 3. So I don't have any setting, that's fine. So I'm going to start data guard broker daemon process by setting it to true. So when you look at pgrep minus daemon, okay, so pgrep minus lf daemon, so it is running. And then what I'm going to do, I will have to change the environment variable to configure logical standby database. So it's got to be London 2 and SQL plus as a sysdba. So first thing what I have to do is I have to stop logical standby background process. So when you look at pgrep minus lf lsp, as you can see, lsp is running. So in order to stop lsp process, logical standby background process, alter database stop logical standby apply. And then I will double check remote log archive destination. Parameter log archive dest2. In this environment, everything is null. So now I'm going to start daemon process, alter system set, data guard, broker, start equals to true. That's a preparation. So finally, you confirm that your daemon is running like this. Okay, so now let's create data guard broker configuration. So I will get into primary database, or you can use new terminal session. I will connect to host 01. And then I can use dg mgrl sys oracle underscore for you at Boston. So I connected. Currently, I don't have a data guard broker configuration, so I can create data guard broker configuration. So I wanted to copy paste, but copy paste doesn't work. Create configuration dr solution as a primary database is Boston. Connect identifier is Boston. So I'm adding Boston database in the newly created configuration, and then I'm going to add the London database. Add the database London as a connect identifier is London. And also I can add the database London 2 as a connect identifier is London 2. So in my demo environment, I have 3 members. So after registering 3 members, when you look at show configuration, and you will see Boston database, London database, and London 2 database. The current data guard broker configuration is disabled. So if you want to enable it, so you can enable configuration, hit enter. So after you enable it, so we're going to check configuration, show configuration. So I have a temporary warning message. First time when you enable data guard broker configuration, it takes a little bit of a time, about 30 seconds, to synchronize all internal settings, and then finally you will see good configuration. So let me actually execute this one more time. Okay, so it's just still. So after waiting a couple of seconds, it should be back to normal. So let me double check. So finally, everything is a success. So I just waited about 30 seconds to 1 minute, and everything came back to normal. Now, in my current configuration, I will have to configure redo transport service. So I will have to transport redo from Boston database to London, and also London 2 database. So I want to transport redo asynchronously, or you can also send it to synchronously as well. So how can I do that? If you want to use redo route, the property, then you can use this, edit database. So what is your sender? Boston database is sending redo. And then we're going to set property, and for the redo route. Now, what is the name of a primary database? Boston database is the name of a primary database. Where do you want to transfer redo? I'm going to send the redo to London database and also London 2 database. And I'm going to send it to two destinations asynchronously. And that's what I can do. So after complete this, I can double check show configuration. So I have the configuration, everything is good. So after this, my Boston database will transfer redo to London database, and Boston database also will transfer redo to London 2 database. So in this case, Boston is a sender, and if Boston database is a primary database, Boston will transfer redo to receiver, London and London 2. So that's how you can configure. So this is a short demonstration. This is first section of a lesson 10. Okay, so let's take a look at second part of a lesson 10. We already discussed creation of a data guard broker configuration. Now we're going to see how to manage data guard broker configuration. In this slide, it is showing you the way to manage two data guard broker services. One is redo transfer service. So you can actually the issue edit database Boston set state transport off. This is to disable redo shipping to destination. And also in the physical standby database and logical standby database, you can issue edit database London in this example, set state apply off. If this were SQL, the SQL prompt, then you have to run two different SQL statements, right? Because if this is the physical standby database, then you have to run alter database, recover, manage it, standby database, cancel. If it is a logical standby database, alter database, stop, logical standby, apply. So you have to run two different commands. But with the data guard broker command line interface, you go with the same command. And also, how do you want to transport redo? So you can also change it, database property. In this example, log export mode is synchronous. So we want to transport redo synchronously. But one thing what we have to know, as a part of a previous demonstration, I showed you a redo route property. If you have a redo route property and also log export mode property that are configured, then data guard broker always takes the value of a redo route property setting. That's a higher priority. So that's one thing that you have to know. Now we have a couple more the properties. So let me briefly go over a couple of properties. So we have apply elect threshold. It generates a warning status for a logical and physical standby database when members apply elect exceed the value specified by property. So that's to receive a warning message if you apply elect exceed your requirement. And also apply elect target. This is a limit amount of data that can be lost and effectively increases the availability of the standby database or far sync instance by forcing a log switch after amount of time you specify elapses. For example, during the less activity time period at night, okay, we have a minimal redo generation. But even though the online redo is not full, we want to archive a log file. Okay, so we can actually the archive log file that is not full. So we can actually specify archive leg target, and also we can use a binding, specify whether redo destination is a mandatory or optional. Is your standby database is a mandatory destination or optional? And also data guard connect identifier. So which net service name is used by data guard broker? And what is the log archive format? And also how many archive processes must be running in the data guard environment? And also we have a log archive means succeed dest. It controls when online redo log files are available for reuse provided by archiving has succeeded to minimum number of destinations. And also we have a log shipping property. It specifies enable or default value of a log archive dest state. So a state of the redo log archive destination can be set through data guard broker property. And we just discussed about log export mode and also maximum failure. We specify maximum number of contiguous archiving fails before redo transport service stop, trying to the transport archive redo destination to the standby database. And also net timeout, how long you want to wait. Okay, in this case, specify number of second log writer wait for Oracle Net Services to respond to log writer request, and it is used to bypass long connection timeout in TCP/IP. So if a primary database, standby database lost the connection, then we're going to mark standby database as an inaccessible standby database if we have a loss of a connection over this net timeout. And also we have an online alternate location. So it specifies alternate online redo log archive location for primary, logical, and snapshot standby. We also have an online archive location. And also we have a redo compression, whether you want to enable compression during redo transfer service. And also reopen second. It specifies the minimum number of seconds before archiver process should try again to access previously failed destination. So Oracle wait until the net timeout, but if a standby database is not accessible over net timeout, then a standby database will be marked as inaccessible or failed destination. But when does Oracle database, primary database, attempt to connect to primary database, standby database again? So that's based on reopen second. So let's say after we detect inaccessible destination, mark it as an inaccessible destination. And every 10 seconds, try again to see if it's possible to connect to the failed destination. So that's what you can set. And also we have a standby alternate location. It specifies alternate disk location to store archived read log files in the standby when the location specified by standby archive log archive location. And also we have a standby archive location. And also we have a transport disconnect threshold. It's also to receive a warning message if a transport leg exceeds your threshold. And also transport lag threshold. You just generate a warning status for logical, physical, and also snapshot standby database file sync instance. When the transport lag exceeds the value specified in second. I think I confused. And this is related to transport lag. And this is when the last communication from primary database exceeds the value specified in second. So that's two different things. So log export mode, we can actually set a log export mode async. So it is to transport redo asynchronously. And we also have a synchronous redo transport service. And also, to transport redo to far sync, we can use a fast sync as well. So this is a diagram that giving you asynchronous redo transport service. If your redo shipping is asynchronous, then the TTNM asynchronous background process, it transport redo to RFS process in the standby database asynchronously. So log writer, it writes redo for committed transaction in the given condition in the primary database, every commit, every 3 seconds, whenever log buffer 1/3 full, and every checkpoint, and so on. So every time when you issue a commit from primary database, as long as your reader for committed transaction is written to disk locally, then we can complete commit statement instead of waiting for synchronous redo delivery to a physical or logical standby database. So it maintains good performance of a primary database transactions. And synchronous redo transport service, this is to achieve zero data loss. Okay, so in order to complete commit statement in the primary database, log writer must write reader for committed transaction to disk, and also reader transport service background process, which called network sync server. It must transport redo to RFS process synchronously over the network. And then we can complete commit statement. So it's a synchronous redo shipping over the network. So it will affect your primary database transaction performance, because we have to wait until message is delivered to physical, and also message returned back to primary database. And also we have a fast sync. The fast sync is we transport redo to standby database synchronously. However, we don't have to wait for synchronous I/O to standby log file. As long as the redo for committed transaction is delivered to RFS background process, then we can complete commit statement. But in the previous synchronous redo shipping, it must wait until redo is delivered to RFS background process, and also redo for committed transaction must be written to standby reader logs. So synchronous I/O, synchronous disk I/O. That's example of a sync. Fast sync is synchronous network I/O and asynchronous physical I/O, disk I/O. So that's two different things. And also there are a couple of new commands that can be used to set and to modify and to display init parameters. So we're gonna see a couple of parameters in next few slides. The first thing is you can change a log archive trace parameter directly in the data guard broker command line interface. So you can specify how much data must be captured. Okay, so that's controlled by using log archive, by setting log archive trace. Since it is init parameter, you can do it through SQL Plus, but you can also do the same task through DataGuard Broker command line interface. And same here, so Boston, and if you want to reset log archive dest back to default value, then you're going to use reset keyword. And also, if you want to change it, log file name convert, we already discussed about this parameter. So in the SQL prompt, I can easily change this parameter if a primary and standby database directory structure is different. And you can also change this parameter using DataGuard Broker command line interface. So edit database, edit file sync, and name and set parameter. If you want to reset this parameter back to default value, then we're going to use a reset keyword. And also, in your DataGuard environment, if there is a zero data loss, redo a recovery appliance, which is an engineer system that maintains backup of multiple target databases. So if you also manage a recovery appliance, you can also set parameter for recovery appliance. So in this recovery appliance, we maintain incremental forever backup, and also real-time redo shipping is enabled. So that's our Oracle engineer system that maintains backup and also backup settings. And also, if you want to reset parameter, db file name convert parameter for recovery appliance named enterprise recovery appliance, then you're gonna set it to you're gonna use a reset keyword. And also, we can set trace level command to set amount of tracing done by DataGuard Broker command line interface. This is a client setting and does not impact tracing set for broker within the database. So we can set trace level user to limit amount of tracing information stored, but if you want to work with the support and support request more information, you can set equals to support. So using example, set trace level support, set trace level user, especially when observer is started, use a trace level close to user. So depending on the trace level, amount of data that will be captured from DataGuard Broker command line interface will be different. So we have a support, and you can set it to a user, so you can change it, the level of tracing. And also, you can disable file sync, and you can also edit file sync to set log archive trace, and you can also enable file sync London. So you can actually set init parameter for file sync as well. And we have a reference here. The listed properties are deprecated, archive lag target, and DataGuard sync latency, and also db file name convert. So if you have to change these properties in 19C environment, instead of using edit database command with the set property keyword, use edit database set parameter and find out corresponding init parameter. So archive lag target has been deprecated. It doesn't mean that this function is disabled in Oracle DataGuard. And same thing here, db file name convert property has been deprecated. It doesn't mean that this function has been disabled. This property itself is deprecated. So another way to set this property is using edit database set parameter. So identify corresponding init parameter for db file name convert. Okay, db underscore file underscore name convert, and then change it value of init parameter, not the property, by using edit database Boston set parameter log archive trace equals to 1, or db file name convert equals to 1 pair or 2 pairs, and so on. And for the logical standby database, we also have deprecated properties. It doesn't mean that functions are disabled. So if you want to change it, these property values, now you can use dbms logical standby apply set and property, which is actually init parameter that is corresponding to this property, and you set it to true or false or any other values. And max connection configuration property is unsupported. And another one is, so I have a data guard broker configuration. I know which command is available to manage a data guard broker configuration and also its members. Just in case, if your broker configuration goes bad because of a data guard broker configuration file corruption, is it possible to recreate data guard broker configuration as is? Yes, it's possible. In 19C, what you can do is you can export configuration to data guard config.txt file. So this will maintain your configuration metadata. So by using this, you can actually import broker configuration back to load all metadata. So you create, just the empty data guard broker configuration and import metadata back. So all the properties and metadata will be synchronized based on setting imported. So that's a possible thing what you can use. So import configuration command allow you to import data guard broker configuration metadata, which could be configuration property, database property, instance property. So these are all imported. So your data guard broker will be synchronized. And also, if a data guard broker configuration is not needed anymore, you can disable configuration. And also, you can only disable database if a database is not recoverable. And also, you can disable file sync. Finally, you can remove database, but preserve destination. So you can remove database configuration completely, but you can only keep configuration. And also, you can remove a file sync, including everything, including configuration information and London file sync as well. And same thing here, you can remove configuration without deleting configuration file. Or you can remove everything, including configuration, in the configuration file. Okay, so we have a quiz. How many data guard broker configuration files are created for each database unique name? We have a primary and secondary data guard broker configuration file. So the answer is B. And edit database set parameter command is to set the database property for the named parameter, named database. No, this is not to set database property. It is to set corresponding init parameter, database init parameter. Okay, so the answer is false. So what I'm going to do, I'm going to pause the recording. I will move on to my demo environment, and I will show you a couple of demos. Okay, so I'm in the demo environment. So let's take a look at a couple of things. Show configuration. So I have a Boston database. I have a London 2. Show database Boston. So it will show you redo transfer service state. So in this case, on. if you want to disable it, so you can actually use edit database command. But if you're not sure about syntax, you can type edit help. So in this case, we have edit database command. So edit database and database name, set state, and then you specify state. So in this case, edit database Boston set state equals to transport of. So I can disable reader transfer service. So when you look at show database Boston, as you can see, intended state is transport of. And also show database London. Right now apply lag is 0 second and transport lag is 0 second. But later on you will see, increasing value in the transport lag section. And also apply on for the London database. If you want to stop MRP background process, edit database London set state equals to apply off. That's what you can run. And after you stop in the host 03, you can check MRP process, it is stopped. That's what you can double check. So if you want to restart MRP process, it's very simple. Just turn it on. And also, you can actually enable reader transfer service again. Edit database London set, actually it's gotta be Boston set state equals to transport on. So I can enable a Boston set transport. Edit database Boston set state transport. I think I made a typo on. So I can actually enable reader transfer service again. Okay, so now what I'm gonna do, let me actually use help export command. As you can see, we have explanation here. Export data guard broker configuration to a file. So I'm going to run this export configuration to data guard config.txt. So it's done. Let's take a look at here. So this is not in our current the working directory. So the default directory of the exported file is a trace directory. So I'm in the Boston database. So I'm going to go to user1 app Oracle diagnostic. And under that, we have a RDBMS product, Boston database, and Boston instance name, and we have a trace directory. So in this location, I should have something file name like this. So I have dg underscore config.txt file. So I'm going to use a gedit dg underscore config.txt. Okay, looks like, okay, since I'm in the host 1, I cannot directly see this way. So more dg config. So as you can see, I have a data guard configuration information. So here, what is the version of a database? What is the data guard broker configuration? What is the default state? What is the DRC? Data guard configuration, unique ID, and what is the failover ID? So all metadata about data guard broker configuration is saved here. So we have an instance name and also a host name, connect string, and so on. So if you have any data guard broker configuration corruption, you can import this back to our current configuration, so we can actually recover all missing information because we have all the exported metadata in the text file, so we can leverage this. So this is a simple demonstration. So in this second part of lesson 10, I focused on the management of data guard broker, and also I showed you the command that will be used, that can be used to manage a data guard broker configuration and each member. This is a lesson 10, second section. Practice 10-1, establishing local and remote connections with the data guard broker command line interface. In this practice, you will use DGMGRL, which is data guard broker command line interface, and connect with both local and remote connections. The password file will be updated on the primary database and copied to every other destination in the data guard configuration. So we're going to start with task 1, locate terminal window on host 01. And if you need, set environment variable with a Boston. As you can see, Oracle OS account, it belongs to many of OS groups. OInstall is Oracle software inventory group, and also it belongs to DBA group, and also data guard DBA group. So Oracle is a member of data guard DBA OS group. So we're going to get into data guard broker command line interface by invoking DGMGRL. And then we're going to connect with the sys data guard. We're going to test with the OS authentication method. So we're going to provide any password. I'm typing any random the password. I'm able to log in. It's an OS authentication method. If your login OS account belong to OS group that is trusted, then you can simply log in without providing valid password. However, when you make remote connection using TNS name entry or LDAP or any other method, then password for user account will be authenticated. So for example, when you connect with the sysdg with net service name and you provide the correct password, when we created a database, we set password Oracle underscore for you. So I'm going to type Oracle underscore for you to see if I can get into it. So it is thinking right now, but I got this message, invalid username and password. The reason is, as a part of a preparation of this course, we had the class build process, and that as a part of it, we created a Boston database, and then we set sys user password and system user password. But all the other administrative account must have its own password. So we have to set password for sysdataguard explicitly. Because during the database creation time, we only set password for sys user and system user account. So what we're going to do, we're going to exit out. And then we're going to log in as a sysdba. And then alter user system data guard, sysdata guard, identified by Oracle_for you. And also alter user sysdata guard account unlock. And then we're going to grant sysdata guard privilege to sysdata guard container equals to all. So we're going to make this user available across all containers in the current environment. And I will exit out. So now what? Since I changed password for administrative user account, it updates password file. If you recall, password file change automatically propagated and automatically updated as a new feature. However, exception is this password file change propagation, it only works for physical standby database and also logical standby database. So in the data guard environment, if you have far sync instance, then automatic password file change will not work. So you will have to copy password file manually. So what I'm going to do, I'm going to execute one script that will copy password file across data guard component. Okay, done. And also I noted in a note here, as of Oracle Database 12c R2, password file change is done on the primary database are automatically propagated to standby database. But there was an exception. Exception is far sync instance. So we have a Boston far sync and London far sync. That's why we had to copy password file manually. So let's test again. DGMGRL. I'm going to make remote connection, just like the first example. I will provide the password. I will make remote connection. Here we go. So I'm able to make connection remotely using net service name. This is practice 10-1. Practice 10-2, creating and enabling a data guard broker configuration. So far, we discussed how to create physical standby database and how to configure far sync instance. And also, we saw how to enable reader transfer service using SQL+ and how to verify using SQL+. In order to simplify data guard management, we can use data guard broker command line interface. And also through the data guard broker command line interface, you can create the configuration that contains component that can be managed through data guard broker command line interface. How to create data guard broker configuration to simplify your data guard management. That's practice 10-2. We will get into host 1 and log in as a sysdba. The prerequisite is you will have to set log archive dest to null, because remote log archive destination automatically updated by data guard broker, so you will have to set it to null. So in host 1, which is the primary database location, I will set it to null. And also third location, which was location for logical standby database, but we will set it to null because this will be updated by data guard broker. And then we're going to start data guard broker process. This is a daemon process. So when you set data guard broker start equals to true, then it will start daemon process. So that's for the configuration of a primary database. Now, we're going to access to Boston far sync location. If you are using existing terminal window, I'm assuming that you already have the environment variables already configured. But if this is a new window, then you will have to set environment variable by using ORA-env script. So I will set it to Boston far sync, and I will log in as a sysdva. In the Boston far sync, we had one remote archive destination, which is London database. Since this destination automatically updated by data guard broker configuration, I will set it to null, and then we will start daemon process. And I'm going to exit out. And that is for configuration of a Boston far sync. Now we're going to move on to London database. That's the third location. And make sure you set environment variable correctly. Now it's very important in HostGetter 3 because you have two separate databases are running. One is a physical standby database, which is called London, and logical standby database, London 2. So depending on where do you connect, it's important to change the worker seed properly. In my case, I will connect to London database first to prepare for data guard broker configuration. And then I will stop redo apply service by executing alter database, recover, manage it, standby database, cancel. And also any remote archive destination must be set to null. And also we will start daemon process. And this is a configuration of a London database. Now I will exit out. Now it's time to configure logical standby database in the same host, ORA-env London 2. So you will have to log in as a sysdva. In this database, we have a SQL apply service. And we can stop SQL apply service by executing alter database stop logical standby apply. And then we're going to update data guard broker start true to start daemon process, which is a data guard broker process. And I want to exit out. At this point, that's your choice. If you want to set it back to London, then you can set it to London, or London, you can leave a London 2, but you have to remember. In HostGetter 4, and this is a London far sync location. I'm assuming that you already configured your environment variable. So I will set it to London far sync, and I will log in as sysdva. And then we will update log archive dest 2, and I will start daemon process. And I will exit out. So as you can see, we updated Boston database in HostGetter 1, Boston far sync in HostGetter 2, London and London 2 in HostGetter 3, and London far sync. Now we're going to come back to HostGetter 1 to get into data guard broker command line interface. And then we're going to make connection. And then you're going to type show configuration. Okay, so we haven't created a data guard broker configuration yet. So we will have to create data guard broker configuration. So command is this. Create configuration called DR solution. In the configuration, we register one mandatory member. That's primary database. This primary database will use Boston net service name. So let me see here. Okay, so data guard configuration successfully completed, and we added the primary database as well. So show configuration. So as you can see, we have a configuration and one member, which is Boston database. And we will also add the file sync, which is called the Boston file sync. And then we will also add the London database. When you do practice activity, make sure you check the configuration one at a time. For my case, I will add all members first, and then I will display the final result. And we're going to also add the London too. And then we're going to add a London file sync. And then I will check configuration. Okay, show configuration. As you can see, in the configuration, we added the Boston database, Boston file sync, London, London 2, London file sync. And then we're going to enable configuration. One thing what you have to know, in this configuration, we haven't added redo shipping and redo transport path yet. We only added the members of a configuration, and we enable this configuration to manage members of a cluster, members of a data guard broker configuration. But in order to transport redo to the right destination, we will have to add more properties. So it takes a little bit of time. Depending on performance of your environment, when you display the status of a configuration, you may receive a series of warning messages. In order to clear all the warning messages, it would take a little bit of time. So you have to rerun show configuration command a couple of times until warning messages disappear. Okay, so my case, my environment was fast enough, so I was able to see the correct message. Now, we're going to add a rule to transport redo to the right destination. The first thing what we're going to do is this: edit database, Boston. So meaning is, Boston database transport redo to Boston file sync synchronously. And we have one condition: if the primary database is Boston. So if a Boston database is a primary database, then Boston database transport redo to Boston file sync synchronously. Makes sense. That's what we discussed. And then you're going to add another property for file sync. Same thing. If Boston database is a primary database, then Boston file sync forward redo to London database and London 2 asynchronously. Makes sense. So Boston transport redo to Boston file sync, Boston file sync transport redo to databases, London and London 2 asynchronously. That's the meaning. And also, if London database becomes primary database, then London should be able to transport redo to London file sync synchronously. And the London file sync should be able to transport redo to Boston database and the London 2 database asynchronously. This is to support role transition service. Finally, we will display configuration status. As you can see, everything is good. So here we have a Boston database. It transport redo to Boston file sync. It transport redo to London, London 2. And members not receiving redo. London file sync is not receiving redo. It only receives the redo if London becomes primary database as a part of a switchover, as a part of a failover. This is for practice 10-2. Practice 10-3, verifying and examine the data guard environment. In this practice, we will review Data Guard Broker GUI interface through Enterprise Manager. To start this practice activity, you will have to start Firefox web browser. Once it comes up, then you enter address https em13c example.com em, hit enter. And then you're gonna log in as a sysman, and password is a cloud_for you. This password already available in the security credential page. So I will get into Enterprise Manager. I will type one more time. So the first page is the database page. If your page is not database page, then you can go to Target and Databases. Then you will see the same page. So we have a Boston database, ORCL database, ArcadDB. Boston is your primary database. So while it's running, let's take a look at manual a little bit. So once you get into Boston database homepage, from the availability Dropbox menu, you can locate Data Guard Administration. So in my case, let me click availability. As you can see, there is no Data Guard Administration because I haven't registered London file sync, Boston file sync as an Enterprise Manager target. So I don't have that option yet. If that is the case, when you click the Add Standby Database, then it will show you database login page. So you can actually use a named credential or new to provide credentials. In my case, in order to see complete information, I will log in as sysdba. And password is oracle_for you, sysdba. I will log in. So I have this information. Now when you look at manual, so if you don't see Data Guard Administration, then you simply click Add Standby, and then you can provide a password. Or sometimes when you click Add Standby Database, it will redirect to Add Standby Database page. So if that is the case, you can simply click Cancel to get into DataGuard homepage. So you are in the DataGuard homepage. So when you look at DataGuard homepage here, we have a DataGuard status, that's normal, and also protection mode, maximum performance. And your primary database is Boston. It's running out of host 01. And also we have a standby databases, which include a FarSync instance, Boston FarSync, London database, London 2, and London FarSync. And also you will see each member's status and also redo source. So when you look at here, London receives the redo from Boston FarSync. Boston FarSync, it receives the redo from Boston. So that's what you can see. So when you look at step number 9 and 10 and also 11, it gives you all this kind of information. So essentially, in our DataGuard homepage in Enterprise Manager, it gives you pretty much a similar information like a DataGuard broker command line interface. So when you type show configuration, it shows you DataGuard broker status information and what's your primary database, what's your FarSync and physical logical standby database, and what is the status. So you can get similar information. And the next thing what you're gonna do, here we have a verification information here. Under the additional administration section, you can click verify configuration. So you can verify your configuration of a DataGuard broker. So it will take a little bit of a time. So here we have progress. It will check a couple of things. And at the end of this verification, you will receive a couple of warning messages, which you can easily ignore. And we can address these warning messages later practice activities. So let's come back here. So we have a verification process. It will initialize environment. It will switch current logo file. It will perform health check and also update DataGuard information and verify fast start failover static services, verify protection mode, checking standby redo log file, and checking DataGuard status, checking properties, verifying log switch, and also saving detailed result. So I'm going to pause recording for a few seconds and I will come back to see final result. Okay, finally it came back to the result page. Here we have a couple of warning messages. These warning messages about Enterprise Manager target name. It doesn't match with the broker name. That's fine. So you can easily change the Enterprise Manager target name. So it's all about agent name and also a couple of warning messages. So we can easily ignore for the moment. So you can click OK. And also you will close this browser. And this is a practice 10-3.